So CCNP stands for Simple Network Management Protocol. So it's quite an obvious name what it's about to do. It was supposed to be a simple protocol which is going to allow for network management. It has three versions: CCNP v1, v2c. v2c came up as an instant update to v2 because of some vulnerabilities, as I remember, of v2. And then they came up lately, within like a couple of years ago, with CCNP version 3. Now, if between version 1 and version 2, let's speak about what CCNP does, and then we're going to speak about the versions. So now the CCNP is, as you're going to see, is used to somehow manage the network. We're going to see for which use cases. In order to achieve its scope, CCNP server uses the concept of MIB, which is the management information based. Is going to use this concept of MIB in order to read status or health information of a network device. Like, you can use CCNP to connect to a device and read its CPU status, its CPU, let's say, current level of what is the current CPU level. And you can also use those MIBs, the management information based, in order to configure the network device remotely. So you can actually change the device's configuration via CCNP. Now, within an CCNP communication, we have two roles: the CCNP agent, which is going to be the network device, and the CCNP manager, which is going to be the CCNP server. Now, as I was saying, CCNP, in order to perform its job, it is based on three main methods regardless of its version. So I'm going to speak in a couple about the difference between the CCNP versions, but most importantly that all of them are running via the same three main methods to achieve its scope. So we have what is called the CCNP GET, which is an action performed by the CCNP manager against the CCNP agent to read device statistics, like for example interface statistics. And this requires read-only access on the remote device on the CCNP agent, and this traffic runs over UDP 161. So for example, if I would have installed on test server A CCNP manager, which means a solution which allows me to manage the network via CCNP, then this and then on the router, which is router 2, this is going to be my CCNP agent. So I'm going to configure router 2 for CCNP functionality, which means I'm going to enable the CCNP agent. And then what happens is that the test server or the CCNP manager is going to send CCNP get actions to router 2 as configured to read specific statistics like interface load statistics, MAC address table statistics, routing table statistics, what is the size of a routing table, interface status up or down, those kind of things. So this is that if you have ever seen those big screens that monitor the network and they show you like what is the current traffic flowing back and forward to a specific interface of a specific device, that is being collected via CCNP. Because CCNP manager via CCNP get commands is going to read the load of specific interfaces, for example, and show you that up in a graph in the application. We have also the CCNP set, which is an action initiated again by the CCNP manager towards the CCNP agent in order to configure the agent remotely, for example, like VTP configuration. This requires read-write access from the manager to the agent, because the manager is going to actually change the agent's configuration. So most commonly seen is going to be like VTP configuration or VLAN configuration, which can be pushed remotely from the CCNP server or CCNP manager. This action likewise runs over UDP 161. That's because both the CCNP get and CCNP set functions are initiated by the CCNP server or manager. Both of them are running over UDP 161. Now the third common method or action which is found within SNMP is the SNMP trap, where in this case the SNMP manager receives unsolicited events from the SNMP agent. Like for example, interface went down. You might say here that, and that's correct, that in this use case SNMP from the traps point of view is going to overlap a bit with the syslog, for example, because also when an interface goes up or down, the router logs a log message which can be sent remotely to a syslog server. So yes, from the SNMP trap point of view, syslog and SNMP have a bit of an overlap, for example. So this action, this method runs over UDP 162 and it's called a trap. It can optionally run over TCP and it's called an inform at that point. So first of all, let's see why it runs over another port, because as I was saying, this action, this method, this specific action is being initiated by the SNMP agent this time, not by the SNMP manager. So what happens is you're going to configure on your network, like on router 2, taking the same example. If server A is your SNMP manager and router 2 is your SNMP agent, then you can configure the agent so that when something happens, like VTP configuration changes or an IPsec tunnel goes down or interface goes down, so based on different, let's say different things happening on the router, you may configure the router to send a trap to the SNMP manager saying, hey, this happened to me. Like, I lost this IPsec tunnel, I lost the VTP configuration, or somebody changed the VTP configuration, or the interface went down, MAC address table changed, I learned a new MAC address. So all those kind of things, it's a lot of traps being supported by the SNMP agent. So this is the one difference between the set, get, and trap messages is that set and get actions are initiated by the manager towards the agent, with the scope of reading some statistics or changing the configuration of the agent, while the trap action is being initiated the other way around, from the agent towards the manager, alerting the manager that something happened on the agent. And because those two are two different, because the set, get, and trap are initiated by different entities, it makes sense that I use different ports to be able to differentiate between those two from the security point of view. Likewise, why would you, speaking about traps, why would you want to run traps over TCP, which is going to be called an inform? For the same reason as we were speaking about syslog, because you would want, so that if the agent has to urgently signal to the manager that something happened, you would want the manager to be able to acknowledge the receipt of the message. So that's going to be what TCP offers. TCP is going to make sure that all packets were received by the destination via the built-in acknowledgement system. Otherwise, using UDP, it could happen that the agent sent the trap to the manager, but it never reached the manager because of network problems, to call it that way.